Hello, friends. Um, Hi, everyone. You guys are there. Hey, guys. Good evening. Good evening. Starting with a very important. Just checking the link. Um, Hello, friends. Hello. हेलो हाँ मैं YouTube के लिंक पे हूँ तो उस पर तो लाइव नहीं दिखा रहा है मेरा वीडियो आ रहा है वो चेक करना आपने लिंक शेयर किया उस पर तो कोई वो फ्रीज है All right. I think there was just waiting for the screen to go live on YouTube. I think we're live. So hi guys, good evening everyone. The exam is nearing, right? And yes, dental materials are a cause of great concern for all of us, right? Mostly we're not studying very hard. Half of us are not understanding this subject in our undergraduate days. Half of the colleges don't have dedicated faculty for dental materials, so it's a multiple composite reasons, right? Yeah, good evening everyone. Wow, wonderful to see you all. Oh, suddenly I'm seeing all these chats now since I've started talking. Great, guys. So let's try to cover as many PYQs, right? Try to go first with the NEET. With cement, first question, which cement has the maximum solubility in the oral cavity? Of course, the options actually gives away the answer here. It's actually a very controversial question, but when you see silicate, right? I mean, there is no doubt about it, right? The moment you see silicate, the answer is there, right? Bang on. Which of these impression materials is incompatible with chlorine? Straight from the table of Phillips, zinc oxide, eugenol. Do not, when you've taken your final impression with after doing your bottom molding, do not immerse your zinc oxide eugenol final impression in chlorine containing disinfectant. Residual monomer content in heat cure, the answer is zero point 0.3 to zero point 0.5. Also remember, for cold cure, it will always be greater. Why? Because the extent of polymerization in cold cure is not as good as heat cure, right? So what is the related application based question that comes related to this? This is obviously memory based, but the application based question is curing shrinkage or polymerization shrinkage or curing shrinkage in cold cure versus heat cure is very interesting. Less for cold cure. It seems very confusing, right? I mean, cold cure is inferior in all aspects than heat cure, right? But it is less for cold cure. Why? Because polymerization has not taken place to the full extent, right, guys? So curing shrinkage for chemical cure or cold cure is in general less than heat cure, right? What else is other important thing regarding denture based resins, or when you say dental polymers? um, uh, color stability is not that great with cold cure, again because there are tertiary amines, and the loss of this monomer and discoloration of this monomer is more. So that's a disadvantage of cold cure. Mostly they're all disadvantages except for this one advantage, that curing shrinkage is less, right? Maximum fluoride releasing restoration. Now guys, this is again uh, again the answer is silicate. And to tell you what, um, if you have silicophosphate in the options, then from the old Phillips, always mark zinc silicophosphate. So follow this order, guys. Silicophosphate has got more fluoride release than simple silicate, which has got more fluoride release than GIC, which has got almost equal fluoride release as resin modified GIC, which has got more fluoride release than zinc polycarboxylate, which has got more fluoride release than Compomer, which has got more fluoride release than Composite, right? So that's the order, right? So here, obviously, the answer is silicate. There's no doubt about that. But in case the examiner tries to confuse you with more options and more interlinked options, like for example, if he gives you both um, zinc silicophosphate as well as silicate in the options, then there's a lot of confusion, right? What should we mark? Silicophosphate or silicate? Then it's zinc silicophosphate. Simply because this I've taken this data from the old Phillips. Right? Accelerators and retarders are added in gypsum to control. See, the best answer is setting time. They also control the setting expansion, of course, but the best answer is setting time. Right? That's a primary function. Yes. Then asbestos, just like cellulose, is what? Is provides for to aid in casting expansion. What all other things are important? So basically, we are looking at the ring liner, right? So let's look at the other important questions that come. That's the crucible former base. That's your sprue. That's your wax pattern. Now, very favorite question of the examiner these days related to this assembly is materials that a crucible former can be made of, right? So it can be made of rubber, wax, metal, even plastic, but never glass, right? So that's a very important MCQ, that crucible former base can be made of all the following except. So the answer is glass. Then what about the sprue or the sprue channel or the sprue pin? It's usually made of wax or plastic, right? So that's another related MCQ. Then the ring liner, usually made of cellulose, that is paper, or asbestos. Other MCQ is cellulose is preferred over asbestos. The reason is, that's another MCQ, that asbestos can be carcinogenic, right? So all these are related MCQs from this. What is also known as small particle filled composite, SPF. So that's your mini filled. Again, data taken from old Phillips, but a new question, right? Came last year only. So that's mini filled, and the particle size range is pretty good, right? It's across one multiple of 10, so like 0.1 to 10, to 1 micron, right? In some references, it's almost zero point 0.2 to say zero point 0.2 to 0.3 to 1, micron, something like that. So that's a pretty broad particle size distribution, and that gives the small particle filled composite a lot of filler loading, because the broader particle size distribution is there, more filler you can add, and that would enhance and improve the physical and mechanical properties. At the same time, the polishability is also not that bad, right? So, which of the following hardness tests is not influenced by the ductility of the material, right? So the answer is Noop, guys. So Noop and Wicker, obviously here, let's just review the answer. Then what are the other related questions? Noop and Wicker both are micro hardness test. Why micro hardness? Both use force levels of less than 9.8 Newton. Both are causing impermanent indentation of up to, if I remember correctly, only 19 microns. That's very less. What are the other important point from Noop and Wicker? Noop uses a rhombohedral kind of indenting tool. Wicker, important point, Wicker's hardness number or test is for standardization and comparison of dental gold based casting alloys, right? That's a very important MCQ, right? Gold based casting alloys. What is the other important thing that comes from Wicker? It is used for the checking the hardness of brittle materials. So in general, tooth enamel, right, and other brittle materials like ceramic, right, you can go for checking their Wicker's hardness number. So these are important things that one should keep in mind. Next question: which of the following, again, this is causing a lot of confusion within our students. So hi DBMCI students. First, castable ceramic, guys, is dicor, no doubt about that. It is a type of glass ceramic. What do we mean by glass ceramic, guys? So basically, you do a controlled heating process that leads to partial crystallization. So in other words, partial deglassing. In other words, partial devitrification, right? So in the amorphous glassy phase, you do some controlled heating process, and that leads to the precipitation of crystals. And in dicor, what is the crystal? That's another MCQ, tetrasilicic flour mica, right? So that's the first castable ceramic, dicor. Tetrasilicic flour mica is the crystal that is generated This process of heat treatment, which leads to partial deglassing or partial devitrification, is also known as ceramic. Of course, this is a method to strengthen the ceramic, and that's how does it do that? These crystals get dispersed in the structure, three-dimensional structure of the ceramic, causing um, uh, acting as a break, acting as an impediment or an obstacle to crack propagation. So this process is known as dispersion strengthening. Right now, so that's all okay, right? So all these are also no things, right? All of them are MCQs. So while you're doing this kind of a question, just rotate in your head all of these important points. A glass ceramic is not just this. Another, yeah. What is causing confusion with our students? Dicor MGC. Now, Dicor machinable glass ceramic is an example of a machinable glass ceramic. It's not castable here. So if it's only Dicor, it's castable. It's Dicor MGC, then it's machinable, right? Machinable means processed by CAD CAM. Next important point, glass ceramic example is not just Dicor. You also have your pressable, like IPS Empress 1, right? Isostatic pressing mechanism in which the crystals are lucite crystals, right? And Emax 2 or IPS Empress 2, in which the crystals are lithium disilicate crystals, right? So this is also modern glass ceramic, which is not castable, but they are made by the kind of similar to an injection molding technique, right? A hot pressing, IPS pressable, injection pressable ceramics, right? All right, so these are all the important points. Red colored abrasive material commonly used to polish, that's rouge. Okay, yeah. One of you, I think one of our students only asked me another question that, you have manufactured abrasives, right? So I told you mnemonic, right? Stars. To remember the manufactured abrasives. T is tin oxide, A is alumina, R is what? R is rouge, S is synthetic diamond, and what is the other S? I think it's silicon. Is it silicon carbide? I'll just check that out, guys. Uh, just a sec. Let's do this before we forget about doing this. Where was I? Yeah, wanted to do this with you guys. Because this was a doubt that was asked by our student only, so I want you to kind of remember this. Hmm. Yeah. Yeah, yeah. Here we are. So stars, right? Silicon carbide, alumina, synthetic diamond, rouge, and tin oxide. So I was right there. These are the manufactured abrasives. And you also have a mineral form of alumina, which is corundum. All right. So I think, I hope that solves the doubt of one of our students. Just remember this mnemonic. I think we should be fine here. हाँ बेटा बताओ कौन सा monolith will have better mechanical properties, beta. Monolith will have better mechanical properties. All right. Where was I? Uh, Serec 123. I'll just check that out, dear. I don't remember the difference between Serec 123. It's just that next generations. So I'll check that out. What's this? Ah, I see. Fine. Where are we? Castable ceramic we've done. Ah, Yeah, so red colored abrasive, that's done. Rouge. Which of the following is true for inlay wax, guys? These are statement based questions that are directly taken from the text. So Carnauba wax contributes greater glossiness to the wax surface than Damar resin. So that's okay. All right. Uh, yes. Yeah. Next is an often repeated question, guys. Sequence of polymerization. So you always start with initiation, then propagation, then chain transfer, and then termination. So that's straightforward, guys. That's from the chapter of dental polymers. Why is it still black color? Yeah. Depicted figure shows what? Shows the Munsell system. What are the other things that you need to remember here, guys? The Munsell system, the three dimensions of color, hue, value, chroma, right? Hue, dominant color of the object. When you say beta classical shade guide A, B, C, D, what does A represent? Which hue? Reddish brown. B represents reddish yellowish. C represents simply gray. D represents reddish gray. So we'll have to memorize this, guys. The examiners are trying to ask more and more questions from shade selection. So I would want you to memorize at least this, right? Then the other controversy is how is the Vita classical shade guide arranged? Now that depends on how you want to arrange it, right? I can keep it like A1, A2, A3, A4, and then B1, B2, B3, B4, but I can also arrange it in the form of decreasing hue value, decreasing values in the order of decreasing value. So highest is B1 and lowest is C4, right? So I can arrange this. Vita Pan Classical, it has 16 shade tabs, right? A has got 5, A1, A2, A3, A3.5, and A4. Then B and C have got 4, B1, B2, B3, B4, and so on. And D has got only 3. So we have a total 16, right? So it depends on me how I want to arrange it. But the question that comes is that value is the most important thing out of hue chroma value, right? And value represents the whiteness or darkness of the color. Next, filler in alginate is composed of, this is often done, it's diatomaceous earth. What are the other important points regarding the MCQs of the composition of alginate? What is the main reactor? Active ingredient is the sodium or potassium or triethanolamine salt of alginate, right? The reactor is calcium sulfate. The retarder is sodium phosphate, right? So first the reaction of calcium sulfate and sodium phosphate takes place. Once the entire sodium phosphate is used up, then calcium sulfate and sodium or potassium alginate react to give the cross-linked three-dimensional brush heap structure, right? In this, there is another very important point, which is what is the gypsum hardener here? Potassium, titanium, fluoride. So please remember this, guys, that potassium sulfate is the gypsum hardener for agar, and its analog or its equivalent gypsum hardener for alginate is potassium titanium fluoride. So they're effectively, their mechanism is the same. They're accelerators of setting of gypsum when you're pouring the cast, right? So these are the important things that come from other important things that come from this topic. Beta, enamel and ceramic, mein ceramic is the answer, right? But if enamel, I shared these values with you also in the group. So one is 85, the other is 75, you know, in megapascal. I'll share them again. But between enamel and ceramic, ceramic is the better answer. Between enamel and porcelain, enamel is the better answer. You understand? Right? There's a difference between porcelain and ceramic. Ceramic is the modern, say, zirconia or alumina based ceramic. They've got very high values of modulus of elasticity, right? Okay, heat energy required in conversion of solid to liquid is latent heat of fusion. That's straight from the book. Dental stone which exhibits least expansion. Now, this is a tricky one. The answer is type 4, and the value is straight from the book, right? They ask me why, sir. Because as you're going from type 1 to 2 to 3 to 4 to 5, the water powder ratio is keeping on decreasing, right? And less water, more powder means you have greater nuclear density. That means greater pushing away effect. So that means the expansion should be more as you go from 1, 2, 3, 4, and 5. Right? Isn't that? Yes, that is true from the perspective of water powder ratio, and that is one of the very important one of the very important things which determine the setting expansion. But there is other things also like the addition of chemical modifiers, accelerators, and retarders. So the manufacturer deliberately, apart from water powder ratio, definitely contributes to greater setting expansion in a type 4 as compared to type 1, 2, or 3 because its water powder ratio is less. But the manufacturer keeps the role of chemical modifiers in such a manner that he reaches the value of water power, of setting expansion lowest in the lowest range for type 4. So the answer is type 4, guys, and this value is taken straight from Phillips, right? And that's the reason. Flux is primarily used to basically remove oxides. So if you talk of fluxes, you have three types. One is type 1 flux, which prevents the formation of oxide. The other is which reduces the oxides. And third is which dissolves the oxides. Right, guys? So the ones which prevent is, I think the options are borates or boric acid, right? Used for gold-based noble alloys, right? And which is a flux which dissolves, that's fluorides, fluoride flux. These are the two most common MCQs, right? These are for base metal alloys, right? So remember this also. Okay, yeah, great controversial question. Find the correct statement of the following cements in ascending order of solubility. Now, guys, solubility, you have distilled water solubility, and you have in vivo solubility. Now, if it's mentioned in distilled water, then obviously out of these conventional cements, GIC has the highest, right? So look for GIC, right? But when it's not mentioned, then in vivo solubility order is GIC lowest. So ascending order, GIC is the lowest. Now then you have zinc polycarboxylate actually. So I'll correct the answer here. Here the answer should be C. Then it's zinc polycarboxylate. Then it's zinc phosphate, and then again it's zinc polycarboxylate in a mixed in a lower powder liquid ratio. Now, if the examiner mentions zinc polycarboxylate in a lower powder liquid ratio, then obviously its solubility is greater than that of zinc phosphate. But if it's not mentioned, then the solubility of zinc polycarboxylate in vivo is less than that of zinc phosphate. So I'm correcting my answer here as per Phillips. So there are a couple of controversial things here, right? One is if it's mentioned distilled water, of course the order completely changes. Then maximum solubility is GIC, minimum is zinc oxide eugenol, and zinc polycarboxylate, zinc phosphate is the same. If it's in vivo, in clinical conditions, that is in saliva, then the lowest solubility is GIC. Obviously, I mean, keeping in mind that resin cement is not there in the option, right? A resin cement has got the lowest solubility. I'm talking of these conventional cements when given in the option, like GIC, zinc phosphate, zinc polycarboxylate. You understand? So then GIC has got lowest solubility, then zinc polycarboxylate, then zinc phosphate, then zinc polycarboxylate in a lower powder liquid ratio. And I'm quoting Phillips here. I'm not making this up. So go with C as the answer, guys. So I'm getting this corrected in our database also. C is the answer, right? Zinc disinfection is a repeat disinfection with chloride based compounds. It should not be done with zinc oxide, eugenol. Passivity of stainless steel, guys. Obviously, chromium oxide. In this, please remember um, the other important MCQs like the austenitic form of stainless steel, martensitic form of stainless steel. Martensitic form of stainless steel is used to make the cutting edges of surgical instruments. Austenitic form of stainless steel is used to make your orthodontic wires, NITI files, your stainless steel files, right? Orthodontic wires and your SS crowns, right? Stainless steel pediatric crowns, right? So that's these are the MCQs that come. Martensitic used to make, it's very hard. So martensitic stainless steel is used to make the cutting edges of surgical instruments, right? Type 2 and type 4 gold fuse. With which type? Ultra low fusing. Why? In general, your gold alloys, their melting temperature is not that high, right? So you want your ceramic, when you're making metal ceramic or PFM crowns, right? So once you get your casting, metal coping, then you want your porcelain to be fired in such a way that your metal, underlying metal, does not sag or does not melt. So you want an ultra low fusing type of ceramic, right? Which is sintering at a temperature of ultra low fusing, which is sintering at a temperature of less than 850 degrees Celsius. And this is true for titanium also. If you're using titanium alloy, although its melting temperature is very high, that is 1668 degrees Celsius, but you don't want your titanium to be subjected to a temperature greater than 850 or 882 degrees Celsius. Why? Because very accelerated oxidation of titanium takes place. It makes it bit brittle, and it's not good for titanium, right? So it won't melt, but its properties will change. Again, straight from Phillips, zinc oxide paste, roll of rosin. It's an accelerator. What else? In zinc oxide eugenol, if you add water, increase the water content, that is also an accelerator. So that's another MCQ. Keep that in mind, right? Minimum water is present in which type of plaster? Obviously, as you go from type 1 to type 2, 3, 4, 5, the water powder ratio keeps on decreasing. So in this plaster is type 1, stone is type 3, high strength is type 4. So obviously the answer is C, high strength, right? Dentist is making an alginate impression. Good impression is not recorded because the material has set quickly. As this is a commonsensical question. When you want to retard your setting time, you or increase the setting time, you use cold water. So probably alginate was mixed with warm water, or your source water, that is water running in the tap of your operatory, is consisting of more salts like magnesium salts, right? So that also accelerates the reaction. Which type of the bond is strongest in abrasives? So guys, this is a often repeated question. Sintered, straight taken from your Phillips. No need to discuss this in detail. Impression of choice for Flabby ridge, guys. This is additional silicone. We've reached this answer with much deliberation with our prosto faculty also. It's additional silicone, no doubt. Green strength, this is a question taken from the chapter of gypsum products. I do this very in great detail in my lectures. Our students at DBMCI know this. This is wet strength. And usually Another MCQ is usually the dry strength is more than wet strength, almost double that of the wet strength. So that's another MCQ that you should. Oh, Delhi is pretty cold, Nami. हाँ बेटा शिल्पा, what are you asking? Surgical instrument. बेटा, हाँ, yes. Cutting surface of the surgical. Yeah, yes. You have to see the question very carefully. Shilpa, I'll have to check this. Which teeth have more accessory? Can I have that? Check that. Direct wax is formed. Good casting requires constant. What is the role of structure? Oh wow, wonderful. In fact, this is something that I was discussing yesterday only, right? In our what was our session yesterday? Ask me anything session with our students. Direct wax pattern. So this is the wax pattern. That's my crucible former base. That's my sprue channel made of wax. Now this dilatation is what? This is a reservoir. Now there's just one wax pattern. So this is an example of direct sprueing, right? And in direct sprueing also you can have a reservoir, and this reservoir is known as a spherical reservoir. What is it doing? It is a storehouse. It's like a dam, right? Containing water. So this is a dam, this is a storehouse of molten alloy. Why? Because it's right there in the heat center of the investment casting ring, right? And it also has a bulk of molten alloy, so it keeps it hot, right? So this provides continuous flow of molten metal in the uh, to the mold cavity, right? And what does that do? It basically prevents premature solidification of the alloy in the sprue channel because it keeps it molten, and whatever solidification is shrinkage is taking place in the investment mold cavity by the solidifying alloy is well taken care of by the continuous inflow of molten metal from this spherical reservoir. So this is preventing localized shrinkage porosity. This is preventing localized shrinkage porosity, guys. So all these are possible MCQs that can come from here. Obviously, you have another MCQ that can come from here, and that is the example of indirect sprueing. So what if I have um, multiple wax patterns, right? And I'm casting them together. So one is of a crown, one is of inlay. And then what I can do is I can connect all these with a transverse bar. So horizontal bar, transverse bar, and then that's your sprue network, which is connected to the crucible former base. So this is known as indirect sprueing. So you can get an image-based question asking what is this assembly? Is it direct sprueing or indirect sprueing? This is indirect sprueing. What is the kind of reservoir here? This is a horizontal or a transverse. Horizontal bar or a transverse reservoir. Right. Again, the function is the same, prevention of localized shrinkage porosity. So obviously the answer here is very simple, guys. What is this? This is a reservoir, and I have discussed all the possible MCQs that come from this kind of an image. Right, guys? Wonderful. Pycnometry, study related to density. That's obviously this is something that all of you must have memorized by now. It's PYQ. Cold cure resin loses color due to oxidation of tertiary amines, right? So guys, basically in cold cure, you have both, you're not using either heat or light, right? So one, you have a source of free radical, right, which is the initiator, and the activator is the tertiary amine, right? And when this kind of get leaches out, it causes discoloration. And this problem is not there with heat cure, right? Or less with heat cure. So oxidation of tertiary amines in cold cure is a big reason for them losing color. Resiliency is what, guys? Resiliency is basically that's my stress strain curve, right? Until my proportional limit, whatever energy is stored in my body is resiliency. So let's see. Energy stored in the material till the proportional limit. That's a straightforward question. Type of internal force which develops within a material when it is stretched. Of course, it's tensile stress. Very simple, guys. Straightforward question. Oh, when what decreases when a material is strain hardened, right? So basically, it's talking of cold working. So we do this chapter in great detail. We do this concept in great detail when we discuss wrought alloys, isn't it? So when you cold work material, it increases in strength, it decreases in ductility. Also, it increases in hardness, but it becomes more brittle. That means its ability to undergo further plastic deformation decreases. So its ductility decreases. And what is the opposite? What is the reversal of this cold working? That's annealing, recovery, recrystallization, and grain growth. So that's another MCQ. What is the how do you reverse these effects of cold working? By annealing. And what is the order of annealing? Recovery, recrystallization, and grain growth. Right. So these are the possible MCQs that come here. Again, just to review, which of the following decreases when a material is strain hardened? The answer is ductility, guys. Yes, guys? Wonderful. Dentist wants an abrasion resistant die, so he tells his assistant to deposit a layer of metal on the surface of impression. This process is called so basically this is electroplating, but a better answer is metallizing, right? And in general, what impression, that's another MCQ, what impression material is usually not metallized? It's usually your hydrocolloids, right? Why? Because they're sensitive to, you can't put them, immerse them in electrolyte because they're hydrocolloids, right? So they'll imbibe the water from the solution, electrolyte solution, and they would undergo dimensional changes. And when you pour a cast after metallizing, it'll be inaccurate. So usually, when you get an MCQ that which of the following cannot be electroplated or metallized, then the answer is either agar or alginate, whatever is given in the option. Right, guys? That's another applied MCQ. Two polymers of different type. So it's basically copolymerization. That's very simple, straightforward. Type of investment. Okay, now type of investment used is determined by. So the answer is type of alloy is also correct, but the melting range of alloy is a better answer. You know why? I'll tell you why. So guys, when you say type of alloy, it's basically mostly what? Noble alloys, gold-based alloys, right? Noble and high noble, right? And then you have base metal alloys, right? Cobalt chromium, nickel chromium, and titanium based, isn't it? Now the thing is that in general, the melting range of cobalt chromium, nickel chromium, titanium based is very high, relatively higher than high noble and noble. But there is a intermediate kind of, you can say, an added thing here, and that is certain gold based alloys which are high fusing. Which are they? They are those gold based alloys which will be used for the fabrication of a metal coping when you're fabricating metal ceramic restorations, right? Because they need to be higher fusing, right? Because they need to sustain the high temperature of ceramics when the ceramics are sintered on them, right? So those gold-based alloys, which are high fusing, guys, which are high fusing, these gold-based alloys, right, should be casted using phosphate bonded investment materials instead of gypsum bonded. So therefore, I say that a better answer is melting range of alloy, right? That's why this is a better answer. So wonderful question actually. Which of these? Okay, so non-aqueous elastomeric has the least shelf life. Guys, here the answer is not direct in the books, but yeah, after much consultation, the answer is condensation silicone, right? And in general, addition silicone and polyethers have got much higher uh, this thing shelf life, right? All right, now this is talking about dimensional stability, guys. Um, of course, this is one correction that I'm doing here in the PYQ. This was not supposed to be here, right? This was marked by A. This is not there in the question actually. This is, say, for example, A, B, C, D, right? And the graph which would represent polysulfide would be the one which is undergoing significant dimensional changes when it is immersed in, say, water or just left on the bench, right? Not poured immediately. But the highest would be with condensation silicon, right? So you talk of dimensional, what you need to remember is dimensional uh, changes in the fit or in the dimension would be least with addition silicone, then polyether, then polysulfide, and then condensation silicone, right? So when you see the y-axis here, linear contraction that takes place, that would be highest with condensation silicone, then polysulfide, polyether, and lowest with addition silicone. Right, guys? Good, great. Rather, I've many a times I've marked this. This correction is still not done here. I just note this down before I forget it. Wonderful. That's why I keep on saying, just keep on revising, isn't it, guys? This correction, I've marked this multiple times. Again, I'm going to go back to my people at the back end and request them to do this. Otherwise, the entire importance of the question goes out, right? Anyways, wonderful, great. Chalo. Uh, okay. This question also, guys. This also is actually shared the correct version. So it was actually a. It came in the exam in this form. This graph was not there. Understand? This was of a equilibrium phase diagram of a solid solution, and they represented, one was like this, A, B, C, and this was A, D, C. So the liquidus state would be everything above A, B, and C. You understand? So I'll tell you how this question was. Yeah, it was like this, right? So just this was, say, A, this was B, and this was C, and this was D, right? So anything above ABC was liquidus, was entirely in the liquid state. Anything below ADC was in the solid state. In other words, ABC is the liquidus curve, ADC is the solidus curve, right? And everything in between represents partial liquid and partial solid coexistence, right? So that is how the exact question was asked. Now this is a smart burr, guys. Although it's a plastic burr, but the better answer is smart burr. This is basically taken from Google only. It was a new question when it came. It created a lot of things. Okay, strength of gypsum bonded investment. Always remember, although gypsum is only 20 to 40%, the strength, this gypsum is the binder, right? So the strength is gypsum. Similarly, in phosphate bonded, the strength is provided by phosphate. It is a refractory, that's silica, right, in the form of quartz or cristobalite, but the strength is due to the binder, and that's gypsum. 18.8 stainless steel represents 18% chromium, 8% nickel, right? That's straight from the book. Dentin bonding agent, of course, consists both of hydrophilic and hydrophobic component. That's straightforward. What is common between dentin bonding agent, pit and fissure sealant, composite? Basically, bisgama. Of course, tegdama is also common, but bisgama is a better answer, right? What is the use of chromium? Increase resistance to tarnish and corrosion. Simple, guys. What is used for stainless steel? For stabilizing the austenitic phase. This is from New Phillips, guys. This is a controversial, but from New Phillips, the answer is nickel only. So remember this. Change in hue perception as light intensity changes is Bezold-Brooke phenomenon, and change in color due to change in the source, light source, is metamerism. Guys, you'll have to memorize these two things. The examiner is definitely going to try and confuse you between these, right? Then commercially pure titanium is welded by which process? The answer is laser. That's simple, straightforward. Which property of the material allows it to be used? This is pseudoplasticity, and this is addition silicone and polyether, right? Simple. Deposition of a layer of metal on impression material to make it more conducting is, better answer is metallizing, right? Electroplating is also fine, but metallizing is the best answer. Okay. Prosthesis failure seen as cement prosthesis interface, the inner surface is smooth, can best be corrected. So basically he's asking that what do you do your microabrasion with? It's 50 micron alumina, right? Okay, now this is again a question. I'll share this. This is actually a very controversial image-based question, which basically I'll share this in the chat box. I've done this. We've done this in the with our students here, guys. I'll just let you know this. Yeah. Yeah. So for our students, guys, I sent this image in the Telegram group also. Send that again. So basically, this was talking about the relative properties between cast alloys versus wrought alloys, right? That was it. Uh, what about the following are the differences of properties between cold cure and heat cure? All of the following are true about the former except, right? Of course, cold cure has got greater porosity, yes. Increased amount of residual monomer, yes. Increased molecular weight, okay. Increase in transfer strength, of course not. Transfer strength is more in heat cure, right? In a tooth with remaining dentin thickness less than 0.5, okay. So that's what is the diagnosis, guys, when the RDT is less than 0.5? It is very deep caries, right? Calcium hydroxide liner has been applied, okay. Then with cement will be used as a base to prevent its dissolution from the etching action of phosphoric acid before placing composite. So guys, basically the idea is that this is the case, right? That's the pulp, that's your... So your RDT is so less that it's less than or equal to 0.5 mm, right? That's your carious lesion. And the diagnosis is very deep caries, not moderately deep, very deep. So there might be a microscopic exposure of the pulp. So traditionally, what do? You apply dical or calcium hydroxide. Obviously, modern day you can use biodentin or MTM. So the examiner himself is saying that you apply dical, right? So you apply dical. Dical is very much, it's the most soluble cement. Calcium hydroxide is the most soluble cement in water, right? So if you want to do a composite restoration, you want to protect it from getting dissolved. while you're doing acid etching. So you want to overlay, you want to protect the die-cal with resin modified GIC. So you do that. If you don't have resin modified GIC, you can apply GIC. Right? So protect it with resin modified GIC, light cure it, and then do your etching, bonding, and composite restoration. So this is basically management of, from the chapter of management of deep carious lesions, right? So we do this very extensively with our students. Wonderful. Uh, okay. Again, in a deep carious lesion, this is straight from Phillips. Restoration is done using liner under a zinc phosphate base. Why? Because, so again, if you have a RDT which is less, and you want to do an amalgam restoration and you've chosen zinc phosphate as the base, it's better to use a liner of Tycal, right, under zinc phosphate. Why? Because of the acidity of zinc phosphate. Right, guys? Because the acidity of zinc phosphate, it can diffuse right across the dentinal tubules and cause irreversible inflammation in the pulp. But this is when the RDT is less, right? And Phillips says again 0.5 mm or less, right? So that's the thing straight from Phillips, right, guys? So I think we've discussed a lot of PYQs. I'm definitely going to mark that image and going to tell this in the chat box both with our students as well as on the YouTube channel for all of you. That question in which there was this confusion going about the relative properties of cast alloys and wrought alloys, right? I'm going to do that pretty soon, and I think it's almost 9 o'clock. So, best wishes, guys, and keep studying hard. Your exam is pretty near, and right, I'll see you. Great, guys. Thank you. See you, guys.